So welcome to our part 2 of the lesson differentiation. Today we are going to look at stationary points or turning points, okay? So basically we say that stationary points are the points where the curve turns. So if you have a curve like this, these points at which the curve turns, they are called stationary points or turning point. Where the curve basically turns, we call that stationary point or turning point. And you must observe one thing here, that at the turning points, the curve is almost flat. Therefore, the gradient is 0. So the argument, the major argument here is that at these stationary points, dy at stationary points or at turning points, dy over dx is equals to 0, because as you can see, the line is almost flat at the turning point. So there is no change in y or change in x, and therefore the gradient function at this particular point is 0. So we call this highest point a maximum point, and we call this lower side a minimum point. And how you basically determine a maximum or a minimum point is by getting the second derivative, that is d squared y over dx squared. So when you find that it is a negative, this means that that is a maximum point, as I will illustrate later. And when you find that the second derivative of the function is a positive, then that is a minimum point. And there are some instances that you find that the second derivative equals to 0. So it is neither positive or a negative. So that one, you refer to that point as a point of inflection. And inflection basically means that the curve turns at this angle here. That is we call inflection. Or when it comes down, it can like this. That is what we call a point of inflection. Otherwise, this is a minimum point, this is a maximum point, and this is a minimum point. So whenever you want to determine the turning points, number one, you're going to get the gradient function. Once you get the gradient function, you are going to get the second derivative or the second gradient function, and then you replace the value of x. When you find it is a negative, you know that is a maximum point. And when you find that the answer is a positive, you say that that is a minimum point. When you find that the second derivative is equals to 0, then we call that a point of inflection. A point of inflection, and that is how the point of inflection normally appears on the graph. So let us look at an example. For example, you are told to find, let me rub this now. This one is important, so let me rub this and then we do an example. So given a question, for example, you can be given the curve y, given the curve y is equals to x cubed minus 3x plus 2. Determine the nature of the turning points. So we have a question here. Given the curve y is equals to x cubed minus 3x plus 2, determine the nature of the turning point. So for us to solve this, number one, we are going to get the gradient function of this. So we are going to say that our dy over dx is, that is 3 squared minus 3. So then we argue that at turning points, dy over dx is equals to 0. So we are going to equate this equation to 0. So that will be equated to 0. Factorization, this will be x squared minus 1 is equals to 0. You divide both sides by 3. So you're going to have x squared minus 1 is equals to 0. You know this is a difference between two squares, so it is like x plus 1, x minus 1. So the value of x can either be 1 or negative 1. Because we found the values of x, we will replace, so you'll help me there. We're going to say at x is equals to 1, what is the value of y? Y will be, you replace 1 cubed minus 3 into 1 plus 2. You will get that. Then at x is equals to negative 1, you will replace the value of y, neg 1 cubed minus 3 into neg 1. Please put the bracket so that we all get the right answer. So what do you have here? 1 cubed minus 3 into 1 plus 2. 0. Then what do we have here? Y, negative 1 cubed minus 3 into negative 1 plus 2. 4. So we have two stationary points here. The first one is this, because I told you a point is given in the form of x, comma, y. So our stationary points will be 1, 0 and neg 1, 4. So that is it. So these are our stationary points. This is how you get stationary points. But for you now to determine the nature, when you want to determine the nature, you are basically needed to declare whether it is a maximum point, minimum point, or a point of inflation. And to do that, I told you, you get the second derivative. This was our first derivative, this one. So we again differentiate it to get the second derivative. So we are going to say our second derivative, therefore, will be d squared y over dx squared to be equals to, that is 6x. So I'll replace at x is 1 so that we know whether at x is 1, we're going to get 6 into 1, which is 6. So this is a positive. And when it is a positive, now you know that point, that at x is 1, when it is a positive, that is a minimum point. Number 2, at x is neg 1, you're going to get 6 into neg 1, which is neg 6. So you know that is a negative. So therefore, you can say that this point here, this point 1, 0 is because it is a positive, so that is a minimum point. Minimum point. And then you say neg 1, 4 is a maximum point. And that earns you 5 marks. 5 to 4 marks, as simple as such. So that is very important. And if they wanted you to sketch that curve, to sketch the curve, you need 3 things. Number 1, x and y intercept. And already we have the x-intercept, so you're going to look for the y-intercept, and also you look at stationary points. Stationary points. So you'll allow me wrap this because you already know how to use this. You'll allow me wrap this part so that we can sketch it here. So when we want to sketch this curve, we have stationary points. We already have the stationary points here. So the only thing we need is x and y-intercept, and x-intercept we already found, so we are going to look for the y-intercept. So to get the y-intercept, you simply say at y-intercept, x is 0. So when x is 0, it nullifies everything here. So the y-intercept is 2. So we have everything. When you are doing curve sketching, you need x and y-intercept, and also you need stationary points, which we found here. So we are going just to sketch. It doesn't have to be accurate, but the most important thing is that you capture the right values. That is the most important thing. You must mark the right values. And also label the what? The Cartesian plane. So we are going to plot these points. For example, 1, 0, we know it is somewhere here. This is the first. Then the other one is here. It is -1. So the first point is here. And then -1, 4 will be somewhere here. So you say here is maybe 4. So that point will be somewhere here. So if here is 4, that point 1, 4 will be somewhere there. And then the y-intercept is as 2. So you write 2 here. So this is the y-intercept 2. It is very important to label them. Now, what we are saying is that now if you want to sketch it, know that 1, 0 is a minimum point. So it takes generally this shape. And then when it is a maximum point, it takes that shape. Good. So when you are curve sketching, you just do this, like this. It must pass through these points. So mine will not be as accurate, but yours will be as accurate. So that one. So you label that this is the graph y is equals to x cubed minus 3x plus 2. So that is a total of 6 marks. As simple as such, you identify the intercepts, the turning points. Then you also identify the y-intercept, and these are the x-intercept, and these are the maximum and minimum points. So thank you. That is done. So we can look at another example for you to understand it better. Yeah, so this is another second example, and the point I'm stressing is that when you are told to sketch a curve, the major things you need are stationary points or turning points, and the other thing you need is x and y-intercepts. And this is another example. We are asked to sketch the curve of s is equals to t cubed minus 6t squared plus 9t plus 5. So what basically we are going to do is, number 1, to get the stationary points. And we said for you to get the stationary points, you're going to say that dy over the dx, of which here we are saying ds over dt because we are differentiating that against that. So there is no problem provided you understand what you are doing. 3t squared minus 6t minus 12t, sorry, minus 12t plus 9. So once you differentiate that, you're going to equate this to 0 because at the turning points, dy over dx is equals to 0. So we are going to equate this 3t squared minus 12t plus 9 to 0. So we are going to get the solution. If you divide all through by 3, you're going to get t squared minus 4t plus 3 is equals to 0. I've divided all through by 3. So our product here is going to be 3. Our sum is going to be -4. Our numbers will be -3, -1. So we're going to say t squared minus 4 minus 3t minus t plus 3 is equals to 0. So we're going to factorize. If you don't understand this, I'll give you a link for quadratics so that you can follow through. So that will be t minus 3, then minus 1 into t minus 3. So we're going to have t is equals to, t minus 1, t minus 3. is equals to 0. So you realize that t is either 1 or 3. Then I said, after you get the value of t, you will get the corresponding values of s at that particular point, so that we give the points in the reference x, comma, y. So you will help me there. We're going to say at t is equals to 1. What is s? And we are going to replace s will be 1 cubed minus 6 into 1 squared plus 9 into 1 plus 5. I don't know what you get. Then you're also going to replace at t is equals to 3. What is the value of s? S will be, you replace, anywhere you see s, you put 3. So that is 3 cubed minus 6 into 3 plus 9 into 3 plus 5. What do you get?
9.
Here you get 9, and then hapo chini you get 5. So you know your two stationary points are 1, 9 and 3, 5. So these are your stationary points. So once you get your stationary points, what you are going to do is to determine whether it is a maximum or a minimum. And I said you get the second derivative. So we are going to work out the second derivative. So that would be you again differentiate this. That is what I mean by the second derivative, d squared y over dx squared. So we are going to have 60 minus 12. So we just say at t is equals to 1, that is 6 into 1 minus 12. You are going to get 6 minus 12, that is neg 6, so it is a negative. Then the other side, you're going to say at t is equals to 3, you're going to say 6 into 3 minus 12, you're going to get 6. So it is a positive. So we said when this one is a positive, it is a minimum. When it is a negative, it is a maximum point. So therefore, you can conclude that 0.1, 9, or you can just say at t is equals to 1 is a maximum point, or you just say the coordinate is this is a maximum point because the second derivative there is a negative. And then the other point now, 3, 5, is a minimum point because you can see the second derivative gives a positive value. So already we've got this. And I said for you to sketch a curve, you need stationary points, which we've already gotten. They are this, and we already know their nature. And then x-intercepts are this, t is equals to 1 or 3. Then now the only remaining thing is to get y-intercept. So we say at y-intercept, x is 0. So when you replace 0 here, everything, you're going to get the y-intercept to be 5, because when you replace this with 0, it nullifies everything. So the y-intercept is 5. So without this, we can now sketch the curve. We can now easily sketch the curve here because we now have all the details we need. So we say this is y-axis, this is x-axis. Now we start plotting. We have 1, 9, so this is 1, then we can put 9 huku juu. So this point here, we have plotted it. We have 3 will be somewhere here. Let us assume 3 is there, 5, so you put that 5, it's slightly above 5. So you mark that point there. Good. You mark it. So we've indicated the intercepts, and we also indicated the maximum and minimum, and then the y-intercept is here. then we know that at 1, 9, it is a maximum. So our curve will move like this. It must pass through the y-intercept first, which is passing through 5, and then it turns at the maximum point, and then it goes like that. So this is a maximum, minimum, intercepts are there, and y-intercept. You just label your curve, that this curve is s is equals to t cubed minus 6t squared plus 9t plus 5. 6 marks. Thank you. I hope we are together up to that point. So follow these procedures to always get it right. So on to our final part, that is the maxima and minima. Basically, this is how far we can get maximum and minimum capacities of various things. And so whenever you're dealing with maxima or minima, it is just the same as equating the dy over dx to 0 at a particular point in order to get the maximum possible value or the minimum possible value. So just say at maximum or at minimum, our differential will be equals to 0. And a good example is here. A rectangular plate has a perimeter of 28 centimeters. So you are supposed to determine the dimensions of the plate that gives the maximum area. And what do we say? We just sketch. We just sketch here. We sketch the plot. This is the plot we are talking about. This is how a rectangular plot looks like. So the perimeter is 28. So we know a plot is normally length by width. And the formula for perimeter is 2 into L plus W will give us the perimeter. So therefore, when we take 2 into L plus W, we are going to get a perimeter of 28. Okay? Dividing all through by 2, we are going to get L plus W is equals to 14. So we can make 1 the subject of the formula. We can say length is equals to 14 minus W. So therefore, with this, making this the subject of the formula, we can now get the area. And we know that area is equals to length by width. So we're going to multiply our length by width. Our new length is this. So we're going to say area is equals to length, which is that width times that length, which is 14 minus W. So our area will be given by 14W minus W squared. And then they want the maximum area. So at maximum area, you know that dy over dx will be equals to 0. So our dy over dx must be equals to 0. So we are going to differentiate this. Okay? So we are going to have 0 is equals to, this is 14 now, minus 2w. Yeah, 2w. You can get that the width now will be equals to 2w is equals to 14, and w will be 7. Okay? So that is the maximum width that will give the maximum area. And for you to get the length, you just replace, and the length will also be 7 when you replace here. So you give the units in centimeters. So whenever you are getting maximum or minimum, once you've got your expression, just differentiate and equate that differential to what? To 0. That is all about maxima and minima. There are several more examples that you can practice, but that is the concept. Once you get the working formula, you just differentiate and equate to 0, you will get the dimensions, okay? So much about the application of differentiation on kinematics or motions, we're going to do later on after covering integration and area approximation, so that you are able then to understand that very well. So we'll have kinematics or motions as a singular topic. So keep following us, keep supporting us, and keep sharing our videos. Until next time, bye-bye.